Hi guys, this is Amin, and in this video we're going to compare sequential programming and asynchronous. Sequential is the regular one that we do in our Python, and asynchronous is a little different. So let's first go to the Blackboard. We'll come back and consider everything line by line in VS Code. To have a better comparison, let's make the Blackboard in half. On one side we have sequential, on the other side we have async. Based on our programming that we're doing so far, we always import a function. Let's say import time, and then we do print hello world. Then we do, let's say, time, sleep, 2 seconds, and then print, I don't know, like, let's say, how is it going? And then again, time, then sleep, let's say 3, and then again print what's up, and keep on doing that. In this one, in the other, on the left hand side, what is happening? The code is just running. Okay, import this one, print this one, wait 2 seconds, do this, then wait 3 seconds, then do this, then do everything. It goes in the sequence, or things are run sequentially. However, in the other side, if we consider the same functions, as we have here, what if while we are waiting, when we have a waiting time 1, so I would say run task 1 and then wait something to finish a task 1, then go to task 2, then you have another waiting time 2. I'm just trying to have this side with a different syntax here. Then task 3, then waiting time 3. What is happening here? I would say, what if while I'm running task 1 and task 1 is done, instead of waiting, or let's say while task 1 is running, it takes time. In that wait time, I might be able to do at least a little of task 3. Or maybe I just come down in the waiting time. The waiting time of this one is 10 seconds. The waiting time of this one is 5 seconds. While I'm running task number 1, which takes 10 seconds, I can leave it behind the scene and it does what it does, and at least have an opportunistic usage, or asynchronous programming, and in async mode run the other task. So when we use the waiting time, if I want to write it, I can say using the waiting time of each task to run all or a part of the other tasks would save us time and cause a little optimization in the performance of our program or script. In fact, we are using our waiting times. In the real world, we can say while I'm uploading something to the server, I'm calling an API and do something. While while posting something on Facebook, like for the waiting time, text a friend. Make the most of your waiting time, and it will be asynchronous fashion. Now we have a little idea about what is happening, and let's stick to our example. What we're gonna do, we're gonna consider a person like Amin's morning routines. Then what will happen? I wake up, probably, then I don't know, freshen up, wash my face, brush my teeth. Then I want to start my day. What I'm gonna do, first thing that I do, I start the breakfast. So I will define a function, and I will call it a breakfast. What I'm gonna eat for my breakfast, I mean, my favorite is walnut cheese and feta cheese and bread. But let's think of omelet. We don't want to make it a lot of names. How long does it take for me to finish it? Sleep, I would say maybe 4 minutes to finish my omelet. And I like the time that Python is yelling at me. Here it is yelling and it is saying, okay, you're missing something. And say, okay, import time. We just import the related library. After 4 minutes, I know this is second, but we want to have a comparison of a like real world. After 4 seconds, what we're gonna do, we're gonna print, okay, delicious omelet. I finished my omelet. Then after that, what will happen? Let's define the next function, which is the coffee for me. So drink coffee like that, and it takes probably 2 minutes. Then I'm gonna print, wow, it was a nice hot black coffee. And very good. And finally, since I'm a lazy person, the first thing that I do, I check my Instagram. Scroll Instagram. And since the social media is the time killer, I'm gonna say for that I spend 5 minutes. Unfortunately, maybe it's more, but anyways. And then when you check all of your notifications and new posts on Instagram, Instagram tells you you're all caught up. You're all caught up. Okay, perfect. Then let's run them. Before running the functions, what I'm gonna do, I would like to keep track of what I'm doing. So I will define the variable start. Then I'm saying this start is equal to time performance scanner. It starts to count the time that I'm working. Then I start my breakfast. Then I will drink my coffee. Is it? Oh, I didn't see what I'm writing. Drink. Then I drink my coffee. Okay. Then scroll Instagram, right? And another variable which I call it end time dot performance counter. Perfect. When everything is done, I would like to see how long was the whole process. So I'm saying it's done in like that and SECO. seconds. And here simply I just say I need n minus start. Okay, perfect. Let's run this one and see what happens. We have an error here, which I'm not sure why it is coming, but it is saying probably I need to open a new tab because I deleted this one. Okay, let me open a new tab. I realized here the terminal Python was open, so I had to go out of Python and run the program. So now it is working. I ran the program and we see here it is saying delicious omelette, it was a nice coffee, you're all caught up, and it was done in 11 seconds and something. Let's see, we have weight of 4, we have weight of 2, and then we have weight of 5, which all be 11 seconds. What is the rest of that? So the performance scanner, this one, it always gives you a float output, and it checks the whole performance of what is happening. Yeah, the waiting time is 11 seconds, but Python, it reads it, since it's a sequential programming, it reads line by line, it checks, and it's the processing time. And if you run the same based on your CPU, the architecture of your computer, you might see a different number. However, so this is why we have a float number. However, we're not really fan of seeing float numbers in this one, so simply I add integer here and I make it an integer. The other thing which is important in the concept of programming is that I made function for everything. I mean, it would be way easier for me to just say start, count the time, sleep, print omelet was delicious, sleep, print coffee was nice, sleep, print Instagram is done, and have the end variable, and everything is done. Why I made everything in functions? In solid principal programming, SOLID, which is the abbreviation, S responsible for single responsibility, and it says we should have functions, and each function must be in charge with one responsibility, and you might end up a human readable script. Let's say that guy, which is like my fictional guy or myself, you are the programmer. He or she gets back to you and says, okay, I changed my routine. I drink organic orange juice, or I changed the omelet to cereal. He or she wants changes, and you delivered the project 6 months before. Now you have to read everything to understand what you did to solve the problem. But if you make it human readable and functions, then it will be way easier for you to solve your problem. And also your program, it gets more complicated, sophisticated, and busy. It's better for the future of your program. Okay, let's save some words. So far we're good. We know it takes 11 minutes. But what if we want to do them interchangeably or asynchronous running the program? What will happen here? While you're waiting for the coffee to cool down, while the omelet is hot, maybe you can scroll a little your Instagram, maybe you can check one email. Basically, the concept is opportunistic usage of your waiting times. While you are waiting for one task to be done, maybe you can use the other task. I'm gonna delete these 3 because we no longer need them. Then these functions, just to have the time, comment them out. Then we do need what? New module, which is async IO. We're gonna work with async IO. I would like to define a new function, but in this fashion, async fashion. Then define, I'm gonna call it breakfast, and in my breakfast, first let's say I'm gonna do print, so omelet, like this. Then probably I should wait a little for something, like, because it's the sleep time. Now I call it wait. Then maybe in that wait time I can have print, let's say, sip of coffee, and then, or I finish my coffee kind of. Then let's say we have a wait time here. Whenever we have a wait time, again, let me call it wait. My next function, async, define, then scrolling, I'm gonna call it like this. Then on scrolling, what we are going to have, print scrolling. So your little scrolling here. Then you have another wait, probably print sip of coffee. Then maybe another wait, then print Instagram is done, something like that. But how do we call all of these waits? The first way that we can run it, I would say, actually the syntax is await, and then we come here and we say async io that sleep, then we give it a sleep of 3 minutes probably, then another wait, then async io, then a sleep, I give it 2, here maybe another. So for Instagram we need the, let's say 3, and then we want to finish up the coffee, so but we are using interchangeably like between them in asynchronous. Async io and then a sleep, maybe 2 here, and in the meanwhile we say you can do await or scrolling. So what happened here? I'm saying start your breakfast, start your omelette, but while you are waiting for omelette to cool down, or while you are doing that, maybe you can await, it's your wait time, go to the scrolling. In the scrolling, maybe you can a little scroll, maybe you can have a sip of coffee, a little omelette, then we have omelette here, a little omelette, Instagram is done, coffee and omelette is done, or are finished, not finished, are served. Let's make it fancier. If I run this, what will happen? I kinda use them inside each other, and to run it you should type async io.run, but which function should we run? The main one, which has a wait inside that, which is the breakfast. So I would say run breakfast like that, and I will run it. So let's see what is happening here. Look at that omelette scrolling. So we have a sip of coffee, we have a little omelette, then coffee and omelette are served, Instagram is done, and everything is done in 8 seconds. Actually, we did the asynchronous one, but let's take a closer look at our program. What we are doing here, we are making the, let me, if I can make it a little better. Okay, anyways, we have the breakfast function here, and then we have the omelette scrolling. We say in that wait time call the other function, but if we make the regular functions like 2 functions, we can call one function in the middle of the other function, so it is still working sequentially but in the asynchronous fashion. So we are not doing asynchronous programming yet. The format is asynchronous, but still we are acting sequentially. But this is one way that we can do that. But if you want the pure concept of that, in fact, you should create tasks. How you do that? At the beginning of your first function, you come here and create task, and you say, okay, async IO. Then you do create a task. Here you put it there, and what is your task? Scrolling, like that. You are saying, okay, we have another function, and you should get rid of that like this. You have another function, and that function is the one that is your task. And instead of waiting this, in fact, you say await for your task. Did you see what happened? We come up with a task, which is the other function. Then we say print omelet. So now what do we need? We need a wait here. Await async IO, maybe sleep like 5. Here your function runs, prints the omelet one, and it says, okay, there is a wait for me here. However, it's asynchronous, and it is redirecting me to the other function, which is to the other task, which has scrolling function, and the other one runs. If I start this one, look at that. We have the omelet, we have the scrolling, and it goes to the next one. Sip of coffee, omelet is done, and time is less than that 12 that we had. So these times, first of all, let me clarify on that one. These times are just some sample times, not necessarily it's the correct output that we are getting, but of course the time will decrease. And as I said, you can say sequential programming is the one that it goes line by line, but the other one, asynchronous, can be the opportunistic usage of the waiting times to run a full task or a part of the other task. So when we call it task, we should define our task, which with this command line, we will be doing that. Sequential programming, asynchronous programming. In the next video, I'm gonna talk about multi-threading and multi-processing, which are two different, kind of comparable with this, but two different. And at the end of that video, I will come up with the conclusion that you cannot say which one is better than the other one. In fact, the program, the nature of your program that you're doing, that it dictates which one you are supposed to do. So see you guys in the next video to compare those two others.